Good evening, everyone. Today we talk about degrees of freedom. I think this is a very interesting, complex but not too much content. So, what is a degree of freedom? Whenever you have a grandeur, whenever you're talking about something in this world, how many numbers, separate numbers, do you need to define univocally that place in this planet or in the world? For example, in space, I can go north, I can go south, I can go east, I can go west. So that's two possible directions, because north and south is the same direction, just in different, just forth and back, right? And then I can go up and down. So that's three. And everybody knows the space is three-dimensional, right? Three. And time, well, the epochal time, how many milliseconds have passed from 1970 is what we use in computer science, or how many years ago was the Big Bang. A single number can put on the single line from the Big Bang to today in times of COVID. So 1 for time. What about a rigid body or the points of a sphere or a bra? I introduced the bra just to increase the visualizations. So let's start from a rigid body, which is probably the most complicated one. If you take this Voltron, this is a beautiful robot. This can be, you could say, well, space is three-dimensional, so the positions that this can assume in the world are three-dimensional, like the X, the Y, and the Z. Close enough, but wrong. Because once you say, for example, you can say in which exact point this is, the sword, the tip of the sword is, but then this can still move. You see, it has an angle here, so it looks like it has, and it can also rotate. So there's actually three more. The answer is actually 6. And if you don't visualize 6, let me help you with that. That's how I feel about it. Take one point, the left horn, 3 degrees of freedom, and the second point, which looks like 3, but actually it's constrained from this radius, so it's actually 2. It can go up and down, right and left, but you cannot get it closer. So this is 3, and this is 2. Or you start with this is 3, and this is 2. It's still 5. Plus, it can still capriolate, and do this. Capriolate doesn't exist, is to get my friend Chiara mad at me. So that's 6, okay? What about the points of a sphere? And now we start talking about Google Maps and what happens on the planet Earth, right? So points in a volume, like in the space, as I said, are tridimensional. So X, Y, Z define univocally your point. But if you want to lie on a sphere or on an apple, 2 numbers are sufficient, theta and phi. Think about this. I'm a cannon and I want to shoot a place on the sky. So I can rotate 360 degrees. Okay, it's here. And then I need to like from 0 to 90, 40 degrees, and I shoot. And that defines univocally the point on the cupola of the sphere where I will hit. For example, this brown point here, which I don't want to hit. So that's 2 angles, and 2 angles define the sphere. But if you think it's quite normal, like when you move on the planet Earth, you move north-south, which is one direction, and east-west, or latitude and longitude. Latitude and longitude, hello, 2 numbers. One is meters, the other 2 are angles, but they still define univocally where it is, right? And actually, the latitude and longitude are quite stupid to me, because one is an angle, the longitude and the latitude is it's kind of an angle, but it's not very obvious to me. And now, what about if my mom comes visiting from Bologna to Zurich? So you say, well, she's on the planet Earth, so 2 degrees of freedom, but what if I know the route that the bus is going to do? The Flix bus goes from Bologna to Zurich, passing from Milan, and Lugano from Chiasso. If it does like that, well, if I phone her, I just need to ask her, how many kilometers did you do from Bologna? And that single number will univocally determine where she is. Of course, in practice, this will not happen, because in practice, she will share via WhatsApp the position, right? But it's very similar to this, right? Think about this. This is a tridimensional object. Are you agreeing with me? Are you agreeing? What is this blue, what is it? This blue tip here. What is the distance between this blue tip and this? It will be around like 62 centimeters, for example. So I can say this blue thing, where is it? 62 centimeters. A single parameter defines it. And now, let me move it. Now it's 65. You see? Very tridimensional body, tridimensional, 3-dimension, but the position of this blue thing here is a single number, is 62 centimeters, for example. So as you can see, it's difficult to navigate between a world of 3 dimensions and things that are actually more or less than that. Let me get esoteric here. How many dimensions are tastes or colors? Now, everybody knows that colors are tridimensional, and if you don't believe me, just Google it. Now, the interesting thing, though, is that you can define spaces of color that are different. Like, for example, I studied in my thesis, RGB is the most famous, HSV is the one used by the Philips Hue application that I have, and I can color differently my light, hue saturation, and then there is a CMKY, which is cyan, magenta, yellow, and something else. So you can use different spaces using red, green, and blue, or red, yellow, and blue, cyan, magenta, and like yellow, azure, and magenta, which is like purple, or hue, saturation, and value. And they're still 3. They're always 3. It changes like the turn, the 3 thing is that you use, but it's always 3. How cool is that? What about the taste? We thought the tastes were 4. We found recently there are 5. Your papillae gustative, your tasting buds, are actually able to collect 5 different things. Savory, sugary and bitter, sorry, that's my son, sour, and umami, which is like taste of algae, Japanese algae or broth. It's a very boring taste, but it's very important for your degustation. So, you see, taste is 5, color is 3, sounds is very complicated. What about more complicated things? There are also moments where the numbers are not so obvious. For example, if you need to model a transistor, you could have a simplified model with 1 degree of freedom, like a resistance. Or you could say the same thing, I use 7 parameters, like 3 resistors and 3 capacitors to define that. Think of a bra. In first analysis, a bra is just the size A, B, C, D, or whatever, I don't know in your language. In Italy, we have a size, which is a number. But you can also have the cup, so you could see all the circumference around your boobie, or you could also see how big the boobie is. And that would be 1 in a simplified word where only size matters, or it could be the circumference plus the size of the boobie, because maybe you are very slim with a big boobie, which is different from very fat with a small boobie, although this parameter is the same, so you might want to use 2. What I'm trying to say here, that in this case, you see that you have like tridimensional space, and you go down to 2 or to 1 dimensions, but you could have also spaces where you start with 1 and you realize that the model is not sufficient to express what you're trying to express, and you need to add other numbers. Usually the more you add, the less information you add. You add little by adding 1 number more, so you need to find the sweet spot, and this is more about modeling. But I hope it was useful. Thank you very much for listening. Ciao!